Hi, I'm recording a few videos on some more advanced art techniques for data science that you will need a lot when you work with more complicated data structures or multiple data sources. And I decided to record videos instead of giving lectures on these topics because they're a bit advanced, they are kind of tricky, and it works better if you have a video where you can go back to certain points or rewind certain points that you might not get the first time. Or maybe if you're experiencing actually trying this out in your own data, then you might find that you didn't really get fully what happened, and then it's useful to have a video rather than lecture to go back to. In this video, I'll talk about the tidyr package for transforming between long format and wide format data, getting your data in the right format so that you can do the visualization you need or the analysis that you need to do. Now to begin, I'll talk a bit about tidy data. So we see this term a lot in data science. This book, R for Data Science, that we use in this course, the course on data science and ecology, use this term a lot as well. And it means that your data should look clean and nice so that you can use it for analysis or merging with other data sets or visualizations or things like that. The idea is that if your data doesn't look good or is not in a consistent form, then it's much harder to use it. With R packages, it's much harder to merge to other data sets. It's much harder to make a picture, things like that. Now, the way the book defines tidy data is that each variable must have its own column. So here we have a data set, and each variable here has a column. And in this case, country, year, cases, population. Each observation must have its own row. In this case, observations are countries by years, actually. And that's an interesting thing already. And each value must have its own cell. So each value should appear in one particular cell. Now, this is nice on paper, but we already see in this example that it's a bit harder in practice to really get your data in a what we call tidy format. Because it's not always clear what's an observation, what's a variable, and how we can nicely separate these in columns and rows. In this case, for example, we see Afghanistan twice, Brazil 2 times, China 2 times. So that means that country is not the observation, but rather country by year is the observation. We could have also had a data set where each row was a country, and that's the observation, and we just measure 2 times depending on the year. Could have also envisioned a data set where each year is an observation, and we have a different column for each country. So it's not always particularly clear when your data is tidy or not, and it actually depends a bit on what analysis you need to do or what picture you need to make, how exactly the data should be shaped. So here I have an example of longitudinal data that we collected, or that's actually like made up data, but that we could have collected in a longitudinal psychological study. So for example, we might give a set of students or subjects in this case a smartphone app that every day beeps at some point, and every day we ask the student to fill in the questionnaire and rate themselves on some variables. For example, sad and anxious. In this case, we have 3 days, Monday, Tuesday, Wednesday. We have 2 subjects, subject 1, subject 2. We have 2 variables, sad and anxious, and some self-report rating. Maybe 1 is very low, 5 is very high. So this data tells me that on Monday, subject 1 responded to the sadness variable with a value of 1. And on Monday, subject 1 responded to the anxious variable with a value of 5. On Monday, subject 2 responded to the sadness value, a variable with a value of 1, etc., etc., etc. So what do we see here? We have in total 12 observations. Right? So in this case, we have 12 different values, actually, what we have here, which you could all call observations. But these are over 3 days. So we see a block here that corresponds to Monday, a block here that corresponds to Tuesday, a block here that corresponds to Wednesday. Over 2 subjects, we have subject 1 and subject 2. So the data of subject 1 is here, the data of subject 2 is here. And over 2 variables. So we have the variable sadness here, variable anxious here. Now, this data looks very tidy. We could call it tidy data, but we see here that actually some things are mixed to it, right? So there are blocks of the days, there are blocks of the subjects, there are blocks of the variables. They're all kind of in there, but in a consistent manner. But yeah, it's not like there's one row for each subject, for example, or unique columns for variables. We might need that if we need to do a particular analysis. For example, let's say we need to use the data for a network analysis. We can use a package called mlvar, which I wrote. It doesn't work with data shaped like this. We would need the data in a different format. Or if you want to do a structural equation modeling analysis, we would also need the data in a different format like this. We would not be able to do analysis with the data like that. We might need to make the data, for example, wider. And with wider, I mean that the data will have more columns and less rows. So it becomes literally wider. So for example, here on the left, we see the long data that we had. It's called long because it has lots of rows and every value, really every unique value is under each other. Right, so these are all like this is subject, variable, day. These are really the values of our data and they're all under each other. We could make it wider and now we have more columns corresponding to the values. Right. Actually, in this case, it's not actually wider. It's only 4 columns and there are 4 columns here. But if there were more variables, we would have had more columns here. Where in the long data, we wouldn't have had more columns here. So let's say we also measure happiness. Then we would have sad, anxious, another column here with happiness. And it would become wider and wider and wider and wider. Like in the examples I gave, structural equation modeling and network analysis, this is the type of data that we would need. We would need the data to look like this. One column for day, one column for subject, and then the variables that we measure next to each other. So now every variable is a separate column. But yeah, we could argue it's still not as wide as we can get it because there's still multiple columns per person. So maybe we want to do an analysis where the person is really the subject or the observation. It's still not wide enough. So we could make it even wider. And we can make a data, we can form the data like this. We have subject 1, subject 2, sadness on Monday, sadness on Tuesday, sadness on Wednesday, anxious on Monday, anxious on Tuesday, anxious on Wednesday. And again, depending on the analysis you want to do, this might also be the way in which you need your data to be structured. For example, certain structural equation model analysis, like the random encyclopedia panel model, would require the data to be structured like this. Other approaches might need this setup. For data visualization in ggplot2, you generally need your data in long format, which works better. Right? It's just to show that it's the same data represented in different ways. You can represent it wider, and yeah, you can even make it more wide. You could just make it one row with like a variable for every variable by day by subject, but there is no need to do that here. But there might be need if these are all, let's say we also have classrooms and these are students, and then we want to make an even wider data with a row per classroom, then we might need to do that as well. So now there's only one row per person, but there are multiple columns per variable, which is also a bit, less nice, right? So there's not really any best way to do this. Either we have multiple rows, we have multiple rows per person, or we have multiple rows per variable, multiple columns per variables. Right? So there's not really any best way to do it, and it's just important that you know how to go from one to the other and back. Okay, so here I have an example data in R. I'll upload a script as well that you can copy paste below, or I'll upload it to Canvas or on YouTube in the comments below, so that you can play around this yourself and play around the data yourself. So this data is the data that I showed before. It's this data here that we have the days, subject, the variables, and the values. Right, so take a moment to make sure it's in R. And just copy the code that I give you. You don't have to type it over from the screen. All right, so this long format is useful for plotting. ggplot really is intended to have data structured like this. And especially here, having multiple rows per variable, having all the variables in one column like this and all the values in another column, is useful if you want to make these types of plots where we have multiple panels, which are extremely useful if you want to really make a big picture of a lot of variables and how they relate to each other. Right, so what happens here is that the y-axis is the value. It's not anxious or sad, right? It's this column value, the value, the height of it, the outcome. That's what we put in the y-axis, right? So here you see y equals value, day static. X equals day. That creates this Monday, Tuesday, Wednesday on the x-axis. And color is set to the subject, which actually is overlapping for anxious, but not for sad. Then we use the variable column in this facet_grid function, which nicely puts them next to each other. There's another way to separate information. We use this column to say, okay, we want these next to each other in different plots, which is very useful. So this form you might want when you might make a ggplot plot for your data, but you might not want it if you do certain analysis. For example, for like a network or vector regression model, as I said before, you might need to have the data in this wide format. So how do we do that? Well, we can use the tidyr package for this. So the tidyr package is a very nice R package. It's designed for making your data tidy, but also to transform your data in a way that you want it. And it has a lot of different functions that you can use, a lot of different ways which you can use them. Some of them are quite complicated, so I just want to give you some examples of simple ways which you can use them. But one of the main functions are pivot wider, pivot_wider, and pivot_longer. So we have here this df_long, this long data frame, looks like this, right? And we want to make it wider. We can use this function pivot wider. So here I use this dplyr pipe operator to send this as first argument here. And then we can say id_cols, the argument for the id columns, equals day and subject. Right, so we have here day and subject. What we want to do is put these variables next to each other with the values under it. So we want to keep a column for day and subject, but we just want to make this wider. That's why we say id calls equals day and subject, so that we keep a column for day and a column for subject. And for each unique value of that, we want to make the rest wider. Then we say take the names from variable. The variable is the column name here. That will put the names of the new columns here. And take the values from the value column here. And this literally tells us, okay, give me a row for each unique combination of day and subject. Make the rest wider. Take the names from this variable and the values from this variable. And we get this nice wider data set where we now have day, subject, and 2 columns for each variable. If there were more variables, let's say with 6 or so, then we would have had 6 columns here rather than 2. What if we need even wider data? Well, we can do the same. So what I do here is I take my wide data that I had. I use this dplyr select function to rename anxious to angst, so that otherwise these column names become very long. I say collect select day, subject, anxious, and sad. So we had day, subject, anxious, and sad already. Just all I do is rename anxious to angst. And I use pivot wider again. So now I want one unique row for each subject. So I say id calls is only subject now and no longer day. And instead I say now take the names from the day, right? So we have this day variable here. I want to use that in the names of my new columns. And take the values from both sad and anxious. So take the values from both this. And so what do I tell tidyr now is I want a wider data with one row for each unique subject. Use the information in the day variable to name the columns and use these values. And what we see here is that tidyr automatically figured out to name columns like this. I said names from day, Monday, Tuesday, Wednesday, but it also understood there were two variables to get my information from, so it made these nice column names, set_month, set_Tuesday, set_Wednesday, etc, etc, etc. And it made this even much wider data where now every row is unique subject, and we no longer have multiple rows per subject, which might be useful if you want to do some form of advanced analysis, like, as I said, the random cross-sec pattern model, which is not part of this course at all. But yeah, you might encounter it at some point that you need your data just to be very wide. Now we did the two steps. We went from long data to wide and to extra wide. We could have done that in a single step. So how do I do that? I take my data. What do I do here? Well, this is another way to just change anxiety or anxious into angst. So substring, substra, is a function in R that just takes the first, in this case, 1 to the 3rd character. Just again to abbreviate this name, so we get angst and not anxious, because otherwise it just would not fit on this slide. And then I say, all I do is I say pipe, right? First mutate, then pipe. One unique row for each subject. Take the names from both the day and the variable, and the values from this value column. Right, so we ignore this. We went straight from this to the extra wide data. So we say, okay, subject for the ID calls, day for the name from, and value from subject for the ID calls, name from day and variable, and value from value. So from this data, we have this ID column. We want one row for each unique value here. Make use for day and variable for the names, and take your values from here. And that's what we do. In this case, we go straight to the extra wide data. But just to show that you can also do this in one go. Now, how do we go back to long data? So if you have this extra wide data, how do we make that again long? Well, that's actually pretty easy. There's a pivot_longer function. And we can just tell tidyr, okay, make this longer, and just collect anything from this to that. That's what this notation says here, this column notation, from the variable set_mon. And actually, we have to go back now to this slide. So this is the first one here to the last one here, angst_wet, which is this one here. It does the rest automatically by itself. So it makes a new variable for the variable name, the value, and the subject. Now this one we might need to split up still, because tidyr does not know that these were two variables combined already, but we can do that with some functions in R. So we can use, for example, the strsplit function to do that. But there's a nice function in tidyr, separate, which you can use to separate these this column here, this name column, into two separate columns here for set, for variable and for day. Its use is a bit weird, but basically it understands that if there's a structure like this with an underscore, those are two combined names. So we just say separate name, and the first thing should be called variable, the second thing should be called day. Then we get this. And we have the same long data that we had before, which works very easy. We could have also done it in a single statement. That's a bit. So here, what I did is I first did pivot longer than separate. You can actually do it in the pivot longer command directly with this names_pattern function, but you have to use some really weird form, which looks a bit like two eyes and a nose that are crying. Some really weird form to do it. This makes sense. if you understand what's happening there, but this might just be easier to do if you need to do this. So how do we go back from the very wide data to the wide data? That's actually a little bit trickier to do. So we had this long data, the wide data, and the very wide data. Yeah, how do we go back? So that's actually pretty tricky to do. So I show you here how I can do it. First, I do it for the set variable. I make it longer for the set variable alone. So I get this, we have the set column, subject day. Then I do it for the anxious variable. So I have the same, right, the same columns here, subject day, but now the anxious column. And then I combine them, which I'll explain in the next video how to do this. Then you can get this like wide data that is not super long, not super wide. But this is pretty tricky. It's actually easier to just go from the fully wide data for the fully long data first and then make it wider again, which is a bit more straightforward to do than to do this. But I just wanted to include this in the lecture and the slide. So yeah, you can see this as well. All right, now this is the tidyr package. In the past, many people relied on the reshape2 package instead. And the reshape2 package is still used quite a lot as well today. So you might see that code as well if you get code suggestion, for example. It works a bit different, but it has some nice methods. Mainly it relies on casting and melting. You can see it like an ice cube. If you have an ice cube, it melts, becomes longer, right? Then if you push it back together and cast it and then freeze again, it becomes wider. Casting and melting. And it uses formula notation. So in this case, I say you take this data frame and then cast it, and then day plus subjects, and make a unique row for each day and subject combination by variable, and then it gets you actually don't say where the values are, it fixes it out itself. You can specify it, but in this case, you don't have to. And that makes this wide data where these are named by variable. Melting is going from wide to long, and it has quite an easy way to use it well. Some people find it a bit more straightforward. We say id vars equals which variables are the IDs variables. In this case, subject day. And so this is from wide to long, right? And which variables have the measures, anxious, set, and let's put those under each other. So you get this long data again. You might encounter this, especially if you read up code online. I just wanted to show that as well. So let's see what it looks like with an example. So here I have the PL445 toy datasets. This is the dataset you filled in week 1, where you just gave a lot of responses on many different things, like what movie you like, what Pokemon you like, stuff like that. And let's add a subject ID column. And then there were some questions in there that ask you how much time and how many hours per week do you spend on doing X, like watch TV or on social media or studying or exercise. So let's select that. We have this data clean, the data object. We use the pipe operator, and we use the dplyr select function, and we select the ID, watch TV, social media, study, exercise columns. Now, there is another commonly used R package called mass, which also has a select function. And if you load the mass package or any package that uses it after the dplyr package, sometimes you get that this gets an error. And I have it especially when I use the select function. If you want to make sure you use the dplyr version, you can always write dplyr colon to make sure that you use a function from the dplyr package to avoid that error. I'll remove this for now because you don't need it, but just a little tip in case you ever get that. Okay, so here I have a smaller data set with 1 row per subject and 4 variables: watch TV, social media, study, exercise. Now this we could consider a wide format data because we have, 1 column for each variable. But we can also see it as 4 columns for one variable, namely time spent on doing X. And what X is then just another variable. If we want to make this a longer format, we can make an easier plot, which would be nice. How do we do that? Say, take this data, then use the pipe operator, then use pivot longer, which is from the tidyr package, which you already loaded before. Pivot longer. Use the columns watch TV to exercise. I think we could actually remove that. You can look at the help file. It's the second argument in this case, but the first argument is already the data used with the pipe operator. So we could just remove this, but I'll keep it there to be clear. So use the column watch TV to exercise. So start with this one, end with this one. So all these 4. All right. Then name the new column activity and the value, the new value column hours. So we get the new data. We have here activity, which is names to. So yeah, that's what the variables. Right, so the names went literally to this activity column. That's what it stands for. And the values went to this hours column. Right, so the names here went to activity, the values went to hours. And we got this new longer data set. That looks like this. Multiple rows per subject, with one unique row for each value. This we can more easily use for plotting. Show it in another video. With, for example, this ggplot statement that I have here. So what do I do here? I say put on the x-axis the number of hours and make a histogram. All right. So I only run this. It would just make a histogram aggregated over all variables. That's not very useful. But we can use this facet wrap or facet grid. It actually, so what facet grid does, it will put it next to each other like that. Facet wrap will instead put it in a nice thing that fits your window well, but it's only used for one variable, not 2. Facet wrap, I use a theme here. I use a scale y continuous to set the bar to start at 0, which is very nice, and to set the maximum here, and to set the label. I use this xlab here to set the x-axis label, and get this nice histogram overview of all the 4 variables. What we see is we see that many people spend about 0 to 20 hours on most things. One person in the data spends 60 hours per week watching TV, which is quite a lot, right? But that's almost 10 hours per day. But yeah, sure, whatever floats your boat. And exercise actually a bit less than the time spent on social media, studying and watching TV. Okay. That's it for this video on data wrangling.